Hi there, I am Earth Mist, and on today's video, we will talk about one of humanity's greatest mysteries and most astonishing achievements, the pyramids of ancient Egypt. But more specifically, we're going to dive deep into the question that has captivated historians, engineers, conspiracy theorists, and curious minds for centuries. Did the Egyptians really build the pyramids? And if they did, how on earth was it even possible? Now, before you click away thinking this is just another conspiracy video, I want you to stick with me. Because what we're going to explore today isn't about aliens or lost civilizations with magical technology. Instead, we're going to look at the cold, hard facts about just how monumentally difficult it would have been to construct these structures, the sheer scale of human effort required, the incredible distances materials had to travel, and why even with our modern technology, we would struggle to replicate these ancient wonders. By the end of this documentary, you'll understand why the pyramids represent not just architectural marvels, but testaments to human ingenuity, organization, and determination on a scale that's almost incomprehensible. So, grab your favorite beverage, settle in, and let's journey back over 4,500 years to ancient Egypt. Let's start with the Great Pyramid of Giza, also known as the Pyramid of Khufu. This isn't just any pyramid. This is the granddaddy of them all, the most famous, the most studied, and arguably the most mysterious. When it was completed around 2560 BCE, the Great Pyramid stood at approximately 481 feet tall. That's about 147 meters for those of you using the metric system. To put that in perspective, it was the tallest man-made structure in the world for over 3,800 years. Let that sink in for a moment. 3,800 years. It wasn't until the construction of Lincoln Cathedral in England in 1311 CE that any structure surpassed its height. But height is just the beginning of this story. The base of the Great Pyramid covers an area of approximately 13 acres. That's about 5.3 hectares, or roughly the size of 7 football fields. The precision with which this base was constructed is staggering. The 4 sides of the pyramid's base are aligned almost perfectly with the 4 cardinal directions: north, south, east, and west. The accuracy of this alignment is within a fraction of a single degree. We're talking about an error margin that would make modern engineers jealous. Now, here's where things get truly mind-boggling. The Great Pyramid is estimated to consist of approximately 2.3 million stone blocks. Let me repeat that. 2.3 million individual stones. Each of these blocks weighs on average between 2.5 to 15 tons. That's 5,000 to 30,000 pounds per block. But it gets even more extreme. Some of the granite blocks used in the King's Chamber weigh as much as 80 tons. That's 160,000 pounds. That's equivalent to about 25 elephants, or 11 fully loaded SUVs. If you were to try to count every single block in the Great Pyramid, and you counted 1 block per second without stopping, it would take you approximately 26 days of continuous counting. But the builders didn't just count them. They had to quarry them, transport them, shape them, and precisely place them in position. Let's talk about the total mass. The Great Pyramid weighs approximately 6.5 million tons. To put this in modern terms, that's roughly equivalent to 900 Eiffel Towers, or about 16 Empire State Buildings. It's a mass so enormous that it actually affects the geological structure beneath it. The sheer weight of the pyramid has caused the bedrock underneath to compress over the millennia. Now, imagine you're an ancient Egyptian engineer, and Pharaoh Khufu comes to you and says, "I want you to build me the largest structure the world has ever seen. It needs to be geometrically perfect, astronomically aligned, and it needs to last for eternity. Oh, and by the way, you don't have steel tools, you don't have the wheel for transport in the way we use it today. You don't have modern machinery, and you certainly don't have computers or calculators. But I want it done in about 20 years. Most modern engineers would laugh at such a proposal, and yet, the ancient Egyptians did exactly that. Before the pyramids could be built, the stones had to come from somewhere. This brings us to our first massive logistical challenge, quarrying millions of tons of stone with ancient technology. The majority of the blocks used in the Great Pyramid came from local limestone quarries located on the Giza Plateau itself. Now, you might think, well, if the quarry was local, that makes things easier, right? Not exactly. Even being local, these quarries were still a significant distance from the construction site, and the sheer volume of material that needed to be extracted was unprecedented in human history. The main quarries were located just south of the pyramid complex, but that's not the whole story. The fine white limestone that originally covered the entire exterior of the pyramid, giving it a brilliant, smooth appearance that would have been visible for miles, came from quarries at Tura, across the Nile River. That's a distance of approximately 13 to 17 kilometers, depending on the route taken. And remember, this is across the Nile, Egypt's massive river. But here's where it gets even more challenging. The granite used for the King's Chamber, the Grand Gallery, and various other internal structures came from Aswan, located about 800 kilometers to the south. That's roughly 500 miles. In ancient times, without modern transportation, moving massive granite blocks this distance was an engineering feat that borders on the miraculous. So, how did they actually extract these stones from the quarry? The ancient Egyptians didn't have diamond-tipped saws or explosives. What they did have was copper tools, stone hammers, and an incredible understanding of the properties of rock. For limestone, which is a relatively soft, sedimentary rock, workers would use copper chisels and stone hammers to cut trenches around the blocks they wanted to extract. They would identify natural fissures and weaknesses in the rock face and exploit them. Once trenches were cut on 3 sides of a block, they would use wooden wedges driven into holes drilled along the bottom. These wedges would be soaked with water, causing them to expand and crack the stone away from the bedrock. Archaeological evidence from ancient quarry sites shows the tool marks left behind by this process. We can see the systematic trenches, the wedge holes, and even some partially extracted blocks that were abandoned, giving us invaluable insight into their methods. But here's something that should blow your mind: the precision with which they could cut these blocks. Many of the blocks fit together so perfectly that you cannot slide a razor blade between them. There's no mortar holding most of these blocks together. They simply sit on top of each other, held in place by their own massive weight and the precision of their fit. This level of accuracy required not just skill in quarrying, but an understanding of geometry and measurement that was incredibly advanced for the time. For the granite blocks from Aswan, the challenge was even more extreme. Granite is one of the hardest stones on Earth, much harder than limestone. Copper tools, which work adequately on limestone, are essentially useless on granite. So, how did they do it? This is where ancient Egyptian ingenuity truly shines. Evidence suggests they used a technique called fire setting, combined with the use of dolerite hammers. Dolerite is an extremely hard volcanic rock, even harder than granite. Workers would pound the granite repeatedly with these dolerite pounders, literally pulverizing the crystalline structure of the granite grain by grain. It's an incredibly labor-intensive process, but it works. Fire setting involved building fires against the rock face to heat it, then rapidly cooling it with water. The thermal shock would cause the granite to crack and fracture, making it easier to work with the dolerite hammers. This process would be repeated over and over until the desired block was freed from the bedrock. Now, let's do some math to understand the scale of labor required. If we have 2.3 million blocks in the Great Pyramid, and it was built over approximately 20 years, that means they needed to quarry, transport, and place an average of 115,000 blocks per year. That breaks down to about 315 blocks per day, or 1 block every 4.5 minutes, working 10 hours a day, every single day for 20 years. Think about that for a moment. Every 4.5 minutes, a new multi-ton block had to be quarried, transported to the site, and precisely placed in position. This wasn't just a construction project. It was an industrial operation on a scale that wouldn't be matched for thousands of years. The quarrying alone would have required thousands of workers. Estimates vary, but most Egyptologists believe that the workforce at any given time numbered between 20,000 and 30,000 people. These weren't slaves, as popular mythology suggests, but skilled workers, seasonal laborers, and craftsmen who were fed, housed, and paid for their work. Recent archaeological discoveries of workers' villages near the pyramids have revealed bakeries that could produce thousands of loaves of bread daily, and evidence of large-scale beer production. These workers were fed a diet rich in protein, including beef and fish, which would have been expensive and reserved for important projects. This was a national effort, requiring the resources and organizational capacity of an entire civilization. The quarrying process also required support infrastructure that's easy to overlook. Toolmakers had to constantly produce and maintain copper chisels, which would dull quickly. Workers needed water, food, and shelter at the quarry sites. Transportation routes had to be maintained. Administrative officials needed to coordinate the work, track productivity, and manage the workforce. When you start to add up all these factors, the hardness of the stone, the primitive nature of the tools, the precision required, the massive quantity needed, and the compressed timeline, the quarrying phase alone becomes almost unbelievable. And yet, the archaeological evidence proves conclusively that the ancient Egyptians not only accomplished this feat, but did so with a level of organization and efficiency that commands respect even by modern standards. So, we've quarried our millions of tons of stone. Now comes what might be the single most challenging aspect of the entire pyramid construction process: moving these massive blocks from the quarries to the construction site. Let's start with the local limestone from the Giza Plateau quarries. Even though these quarries were relatively close to the pyramid site, we're still talking about moving multi-ton blocks across rough desert terrain. The ancient Egyptians didn't have wheeled vehicles suitable for this task. While they had wheels for pottery and may have used them for some applications, there's no evidence of large wheeled carts being used for the heavy transportation required in pyramid construction. Instead, they use sledges. A sledge is basically a large, heavy sled made of wood. The stone block would be placed on the sledge, and then teams of workers would pull it using ropes. Now, you might be thinking, that sounds simple enough. But let's run the numbers on what this actually entailed. A typical limestone block weighing 2.5 tons requires approximately 50 men to move it on a sledge across sand or desert terrain. That's assuming optimal conditions. For the larger blocks weighing 15 tons or more, you'd need teams of several hundred workers just to move a single block. But here's a fascinating discovery that was made by physicists. Studying this problem, the Egyptians had figured out a crucial technique. There's an ancient Egyptian tomb painting that shows workers pouring liquid in front of a sledge carrying a large statue. For years, people thought this was just ceremonial. But modern physics experiments have proven that wetting the sand in front of the sledge reduces the friction by about 50%, making it twice as easy to pull the load. This technique works because the water causes the sand grains to stick together, creating a firmer surface. Too little water, and you're still pulling through loose sand. Too much water, and you create mud. The ancient Egyptians had figured out the exact optimal moisture content through trial and error, demonstrating an intuitive understanding of physics that wouldn't be formally described until thousands of years later. Even with this technique, moving a 2.5-ton block 1 kilometer would require enormous effort. The workers would need to pull in unison, coordinated by overseers calling out rhythmic chants to keep everyone synchronized. They would need to rest frequently. The ropes themselves, made from natural fibers, would need constant inspection and replacement as they wore out from the strain. Now, let's talk about the really challenging transportation: the Tura limestone, and especially the Aswan granite. The Tura limestone quarries were located across the Nile River. This means the blocks had to be loaded onto boats, transported across the river, and then unloaded on the other side. The Nile is not a small river. At various points, it's over a kilometer wide. Building boats capable of carrying blocks weighing several tons would have been a major engineering challenge in itself. Evidence suggests the Egyptians used large wooden barges for this purpose. Wood was actually relatively scarce in Egypt, so constructing a fleet of large barges represented a significant investment of resources. These barges would have been dozens of meters long and reinforced to handle the enormous weight. Loading and unloading would have been carefully orchestrated operations. Too much weight in the wrong place could capsize the barge or cause it to take on water. The blocks would need to be carefully balanced. Ramps would need to be constructed down to the water's edge to allow the sledges to be pulled aboard. The journey across the Nile would have been done during the annual flood season when the river was at its highest. This served two purposes. First, the higher water level meant the river came closer to both the quarry and the construction site, reducing the overland distance. Second, the slower current during flood season made navigation safer and easier. But the Aswan granite presents a transportation challenge of an entirely different magnitude: 800 kilometers, 500 miles, with blocks weighing up to 80 tons. To put this in perspective, an 80-ton granite block is so heavy that it would require a team of over 1,500 men just to pull it on a sledge across flat ground. But the journey from Aswan to Giza isn't flat. The Nile flows north, which means the current would assist in the journey, but the river winds and has cataracts, rapids, that would need to be navigated. The barges required to transport these granite megaliths would have been engineering marvels in their own right. We're talking about vessels that would need to be over 60 meters long and constructed to handle dozens of tons of cargo without breaking apart. The ancient Egyptians would have needed to understand principles of buoyancy, weight distribution, and structural engineering to build such vessels. The journey from Aswan to Giza would have taken weeks, possibly months for the largest stones. The barges would have needed crews to navigate, teams on shore to assist when the barges needed to be pulled past cataracts, and support infrastructure all along the route. Guards would be necessary to protect these valuable cargoes. Supply boats would be needed to feed the crews during the long journey. When you multiply this effort across all the granite used in the pyramid, and remember, we're not just talking about a few blocks, but dozens of enormous stones for the king's chamber alone, plus more for the queen's chamber, the grand gallery, and various other internal structures. The logistical accomplishment becomes staggering. Modern engineers who have studied this problem have been honest in their assessments. They're not entirely sure how they would accomplish the same task today without modern equipment. Yes, we have cranes and trucks and cargo ships, but to deliberately choose to transport 80-ton blocks across 500 miles using only ancient technology? Most would say it's theoretically possible, but practically insane. Yet the evidence is irrefutable. The granite is there, in the pyramid. Chemical analysis confirms it came from Aswan. The ancient Egyptians didn't just move a few of these megaliths for show. They incorporated them extensively into their grandest structures. One researcher calculated that the total manpower required for transportation alone, just moving the stones, not quarrying them or placing them, would have required tens of thousands of workers. These workers would have needed to be coordinated across vast distances, supplied with food and equipment, and organized into efficient teams. The administrative apparatus required to manage this operation would have been incredibly sophisticated. Records would need to be kept of where stones were in the transportation chain. Schedules would need to be coordinated so that stones arrived at the construction site when they were needed, not too early and not too late. Officials would need to manage the workforce, resolving disputes, ensuring adequate supplies, and maintaining discipline. Some historians believe that the pyramid projects weren't just about creating royal tombs. They were also massive public works projects designed to unify Egypt during the annual flood season, when agricultural work was impossible. By organizing the entire nation toward a common goal, the pharaohs reinforced their power and created a sense of shared national identity. But regardless of the political and social motivations, the bottom line remains. The ancient Egyptians moved millions of tons of stone across distances ranging from hundreds of meters to hundreds of kilometers, using technology that seems impossibly primitive by modern standards. And they did it with a level of success that we can observe and measure 4,500 years later. Now, we arrive at perhaps the most debated and mysterious aspect of the entire pyramid construction process. How did they actually build the pyramids? How did they lift multi-ton blocks hundreds of feet into the air with such precision that the structures have survived millennia? This is where the theories multiply, where engineers scratch their heads, and where the ancient aliens crowd starts muttering about levitation and lost technology. But let's set aside the fringe theories and focus on what engineers and archaeologists actually believe happened, based on evidence, experiments, and logical deduction. First, let's establish what we know for certain. The pyramids were built layer by layer, course by course, from the bottom up. This much is obvious from examining the structure. Each layer consisted of blocks laid side by side, creating a flat surface upon which the next layer would be built. As the pyramid rose, each successive layer was slightly smaller than the one below it, creating the characteristic stepped appearance. The pyramids were originally covered with smooth casing stones made of fine white Tura limestone, which gave them their finished, gleaming appearance. But most of these casing stones have been removed over the centuries to be used in other buildings. The real question is, how did they get the blocks up there? The most widely accepted theory among Egyptologists is that the ancient Egyptians used ramps. But not just any ramps. This is where it gets complicated and where different theories diverge. The simplest theory is a single straight ramp that ran from the ground up to the current construction level. As the pyramid got taller, the ramp would be extended and raised. The problem with this theory becomes apparent when you do the math. To maintain a workable incline of about 10%, which would be necessary for teams of workers to pull heavy sledges upward, a ramp reaching the top of the Great Pyramid would need to be over a mile long. The volume of material required to build such a ramp would be enormous, possibly exceeding the volume of the pyramid itself. And there's no archaeological evidence of any such massive ramp structure. Another theory proposes a spiral ramp that wound around the pyramid as it was built. This would solve the length problem, as the ramp could maintain a reasonable incline while spiraling upward. The issue with this theory is that it would cover the sides of the pyramid, making it difficult or impossible for the builders to check the accuracy of the angles and alignment as they worked. It would also make it challenging to place the outer casing stones with precision. A more recent and compelling theory, proposed by French architect Jean-Pierre Houdin, suggests an internal ramp system. According to this theory, the bottom third of the pyramid was built using an external ramp. Once the pyramid reached a certain height, the ramp was dismantled, and subsequent construction used a ramp system built inside the pyramid itself, spiraling upward within the structure. This internal ramp would have been incorporated into the pyramid structure and sealed once construction was complete. Houdin's theory is supported by some intriguing evidence, including microgravimetry scans that show possible voids in the pyramid consistent with internal ramps, and architectural features that seem to serve no purpose unless they were part of a ramp system. However, this theory remains controversial and unproven. The truth is, we don't know for certain which method or combination of methods was used. What we do know is that whatever method they employed had to meet several critical requirements. First, it had to allow teams of workers to pull or push heavy blocks upward at a steady, sustainable pace. Remember, we're averaging one block every 4.5 minutes. The system had to be efficient. Second, it had to provide access not just to the center of the pyramid face, but to the edges and corners, where precise placement was crucial for maintaining the pyramid's geometry. Third, it had to accommodate different types of blocks and different construction phases. The massive granite blocks for the king's chamber, weighing up to 80 tons, would require special handling compared to the average limestone blocks. Fourth, it couldn't compromise the structural integrity of the pyramid or make it impossible to place the outer casing stones with precision. Let's talk about the human effort required to move blocks up these ramps, whatever form they took. A 2.5-ton block being pulled up a 10-degree incline would require approximately 60 to 70 workers pulling in unison. The ramp's surface would need to be kept smooth and potentially wetted, just like the sand technique we discussed earlier. Workers would need stable footing. The ropes would need to be strong and regularly replaced. For the larger blocks, the numbers become almost comical. A 15-ton block on the same incline would require several hundred workers. For the 80-ton granite blocks destined for the king's chamber, you'd need a team of over 1,000 workers pulling together, assuming optimal conditions. But here's where it gets really interesting. The ancient Egyptians may have used lever systems and counterweights to assist in lifting the blocks. There's evidence that they understood and utilized simple machines, levers, inclined, planes, and possibly even a primitive form of pulley system using ropes and wooden scaffolding. Experiments conducted by modern engineers have shown that with the clever use of levers and fulcrums, a much smaller team of workers can lift extremely heavy weights. By positioning wooden beams under a block and using them as giant levers, workers could lift one end of a block, insert packing material underneath, then repeat the process on the other end, gradually raising the block inch by inch. It's slow, but it works, and it requires far fewer people than dragging the block up a ramp. Some researchers believe that a combination of methods was used: ramps for transporting blocks most of the way up, and then lever systems for fine positioning and for the final stages of construction as the pyramid neared completion and ramps became impractical. Once a block was in position, it needed to be placed with incredible precision. Remember, these blocks fit together so tightly that you can't slide a blade between them. This level of accuracy would have required careful measurement and adjustment. Workers would use wooden rollers, levers, and probably simple bronze or copper measuring tools. They would need to check not just that the block was in the right position horizontally, but also that it was level and at the correct angle relative to the pyramid's overall geometry. The tools available to Egyptian workers were surprisingly basic by our standards: copper chisels, wooden mallets, stone hammers, measuring ropes, plumb bobs, and squares for checking right angles. There's evidence they used a tool called a merkhead, a primitive but effective instrument for astronomical observation and alignment, which would have helped ensure the pyramid's orientation to the cardinal directions. They also used something called a wooden square level, essentially an A-frame with a plumb bob hanging from the apex. When the sides of the triangle were equal and the plumb bob hung directly down the center, the surface was level, simple but effective. What's remarkable is how they maintained accuracy over such a massive structure. The base of the Great Pyramid is level to within 2.1 centimeters across its entire 230-meter length. That's an error margin of less than 1 part in 10,000. The sides align to the cardinal directions to within 3 arc minutes. That's 1/20th of a single degree. These aren't just impressive achievements, they're almost incomprehensible given the tools available. To maintain this accuracy, the ancient Egyptians must have had sophisticated surveying techniques and quality control measures. There would have been master architects and engineers overseeing the work, constantly checking measurements, making corrections, and ensuring that each phase of construction met their exacting standards. Think about the pyramid construction site at its peak. Thousands of workers swarming across the structure, some pulling blocks up ramps, others positioning blocks, teams working on different levels simultaneously. Stonecutters making fine adjustments to blocks that didn't quite fit. Engineers checking measurements and consulting plans. Overseers coordinating the various teams. Supply lines bringing fresh blocks from the quarries. Water carriers keeping the sand wet on the ramps. Tool makers repairing and replacing worn-out equipment. It would have been organized chaos on a scale that's hard to imagine. And yet, it worked. It worked so well that the structure they created has outlasted their entire civilization by thousands of years. One of the most convincing pieces of evidence that the ancient Egyptians built the pyramids using methods we can understand, if not fully replicate, comes from the pyramids themselves. We can see the evolution of pyramid construction technology over time. Earlier pyramids, like the Step Pyramid of Djoser, show a cruder, more experimental approach. The bent pyramid shows clear signs of a change in construction technique mid-project, resulting in its distinctive bent profile. The ancient builders learned from their mistakes and their successes, gradually refining their methods. The Great Pyramid represents the pinnacle of this technological development, but it's not anomalous. It fits into a clear progression of increasingly sophisticated construction techniques developed over several generations. This is exactly what we'd expect if these structures were built by human beings learning and improving their craft, not the result of some sudden influx of advanced technology. Modern experiments have also shed light on these construction methods. In the 1990s, engineer Mark Lehner and stonemason Roger Hopkins led a team that built a small pyramid using ancient Egyptian techniques. They quarried limestone blocks using copper tools and stone hammers, transported them on wooden sledges, and raised them using a ramp system. Their conclusion? It's absolutely possible to build a pyramid using ancient technology. It's incredibly labor-intensive and requires excellent organization and planning, but it can be done. Similar experiments have been conducted, moving massive blocks using only ropes, wooden rollers, and human muscle power. Time and time again, these experiments have demonstrated that while the task is extraordinarily difficult, it's not impossible. It just requires vast amounts of human labor, excellent coordination, and clever application of simple mechanical principles. The construction of the pyramids represents human achievement at its most impressive, not because it required alien intervention or lost super technology, but because it required thousands of people working together toward a common goal with discipline, skill, and determination sustained over decades. That's the real miracle of the pyramids. They show us what human beings are capable of when they're properly organized, motivated, and led. Now, let's address a claim that's often made in pyramid mystery documentaries. We couldn't build the pyramids today, even with modern technology. This claim is used to suggest that the ancient Egyptians must have had help from some advanced, unknown source. But is this claim actually true? Could we, or couldn't we, build a pyramid today? The answer is complicated, and it depends entirely on what we mean by build a pyramid. If the question is, could we physically construct a building with the same dimensions and mass as the Great Pyramid using modern technology? Then the answer is absolutely unequivocally yes. We could do it, and we could do it relatively quickly. Modern construction equipment makes the pyramid construction process almost trivial by comparison to what the ancient Egyptians faced. Tower cranes used in modern construction can lift hundreds of tons to heights of hundreds of meters. The largest mobile cranes in the world can lift over 1,000 tons. We have massive dump trucks that can haul 400 tons of material in a single load. We have precision surveying equipment that uses lasers and GPS satellites to measure distances to within millimeters over kilometers. If we wanted to build a replica of the Great Pyramid today, we could do it in a fraction of the time it took the ancient Egyptians. We could quarry the blocks using diamond-tipped saws and explosives, cutting through limestone and granite like butter. We could transport them using heavy trucks and cargo ships equipped with container cranes. We could lift them into place using tower cranes positioned throughout the construction site. We could measure and align everything using computer-controlled surveying equipment. In fact, modern engineers have estimated that with current technology and an adequate budget, a replica of the Great Pyramid could be constructed in as little as 5 years, possibly less if you really threw resources at the problem. That's a quarter of the time it took the ancient Egyptians. So, why do people say we couldn't build the pyramids today? There are several reasons, and some of them are actually valid, just not in the way that mystery enthusiasts think. First, there's the question of cost. Building a replica of the Great Pyramid would be extraordinarily expensive. We're talking billions of dollars. The stone alone would cost millions. The equipment rental would cost millions. The labor would cost millions. The project management, engineering design, site preparation, and all the other costs would quickly pile up. So, in one sense, we can't build it means we can't justify the enormous expense for what would essentially be a massive, useless stone monument. Second, there's the question of method. When people say we couldn't build it, what they sometimes mean is we couldn't build it using the same methods the ancient Egyptians used. And you know what? That's probably true, but not because those methods were superior to ours. It's because we don't know exactly what those methods were, and more importantly, we don't have a workforce trained in those specific ancient techniques. Think about it. Could modern construction workers quarry 2.3 million blocks using copper chisels and stone hammers? Could they transport 80-ton stones 500 miles using wooden barges? Could they lift blocks into place using only ropes, wooden levers, and human muscle power? Technically, yes. Practically, it would be absurdly inefficient, and we'd need to train tens of thousands of people in techniques that have been obsolete for thousands of years. There's also a third interpretation. We couldn't build it, meaning we lack the social and political structure to organize such a project. Ancient Egypt was a highly centralized society where the pharaoh had absolute authority to mobilize the entire nation's resources toward a single project. The pyramid projects represented a significant portion of ancient Egypt's GDP, sustained over decades. In our modern democratic capitalist societies, it would be nearly impossible to get the political consensus and sustained funding for such a project, especially one that served no practical purpose. But here's where the discussion gets really interesting. While we could easily replicate the pyramids using modern methods, there are some aspects of ancient Egyptian craftsmanship that we would find challenging to match. The precision of the stone cutting and fitting is one example. While we can cut stone with incredible accuracy using computer-controlled diamond saws, the economic reality is that we wouldn't. Modern construction relies on mortar and concrete to fill gaps and hold stones together. We've lost the economic incentive to cut stones with the obsessive precision the ancient Egyptians achieved. They had virtually unlimited labor but limited tools. We have incredible tools but expensive labor. So, our construction methods have evolved differently. Some researchers have tried to replicate the tight-fitting joints of pyramid blocks using modern tools and methods, And while they've succeeded in small-scale demonstrations, scaling that up to millions of blocks would be challenging not because it's technically impossible, but because it's economically irrational in a modern construction context. There are also some specific mysteries about ancient Egyptian stone working that remain unsolved. For example, there are some artifacts from ancient Egypt, like certain granite vases and statues, that show evidence of being worked with a precision and in ways that are difficult to explain using only the tools we know they possessed. Some researchers have suggested they may have had access to harder cutting materials than copper, possibly iron tools, even though Egypt was supposedly in the Bronze Age, or perhaps specialized techniques we haven't yet figured out. But these mysteries are about specific artifacts and techniques, not about whether the pyramids themselves could have been built by ancient Egyptians. The evidence overwhelmingly supports that they were. Another argument often made is about the alignment and astronomical relationships encoded in the pyramid's dimensions and orientation. The Great Pyramid is aligned almost perfectly to true north. Its dimensions encode various mathematical constants, including an approximation of pi. The layout of the three Giza pyramids may correlate with the belt stars of the Orion constellation. Surely, the argument goes, such sophistication proves the involvement of advanced knowledge beyond what ancient Egyptians should have possessed. The counter-argument is equally compelling. The ancient Egyptians were sophisticated mathematicians and astronomers. They had to be. Their entire agricultural calendar depended on accurately tracking the stars and the annual Nile flood. They had thousands of years to develop these skills before the pyramids were built. The mathematical relationships found in the pyramid's dimensions may have been intentional, or they may be the natural result of using certain standardized measurements and proportions that the Egyptians favored aesthetically. As for the astronomical alignments, these could be achieved with patience and careful observation over multiple years. The ancient Egyptians had both. They didn't need telescopes or computers to track the stars. They had the advantage of extremely clear desert skies and unlimited time to make observations. Moreover, we need to be careful about retrofitting modern mathematical knowledge onto ancient structures. If you take any complex structure with many measurements and start looking for mathematical relationships, you'll find them. Some of them will be intentional, others will be coincidental. Separating the two is a challenge that has led to a lot of questionable claims about the pyramids predicting various things or encoding advanced knowledge. The bottom line is this: saying we couldn't build the pyramids today is misleading at best and outright false at worst. We absolutely could build them using modern technology, and we could do it faster, cheaper, in terms of labor hours, and with greater precision than the ancient Egyptians. What we couldn't do is replicate the exact same social, political, and economic conditions that made the original construction possible. We couldn't mobilize tens of thousands of workers for decades on a project with no practical utility. We couldn't justify the expense. We couldn't replicate the cultural and religious motivations that drove ancient Egypt to create these monuments. But the physical construction, that's the easy part. The real challenge the ancient Egyptians overcame wasn't a technical one. It was organizational, logistical, and social. That's what makes their achievement so remarkable. Let's talk about something that often gets overlooked in discussions about pyramid construction: the people who actually built these monuments. Who were they? How were they organized? What was daily life like for a pyramid worker? For a long time, popular culture perpetuated the myth that the pyramids were built by slaves, probably Hebrew slaves based on a misreading of biblical chronology. This image has been reinforced by countless movies showing whip-wielding overseers forcing miserable slaves to drag stones under the blazing Egyptian sun. The archaeological evidence tells a completely different story. In the 1990s, archaeologist Mark Lehner and his team discovered the remains of workers' villages near the Giza pyramids. These weren't slave quarters, they were purpose-built communities with bakeries, breweries, copperworking facilities, and comfortable housing. The workers were fed a diet that included bread, beer, beef, and fish. Beef in ancient Egypt was expensive and generally reserved for important occasions or important people. The fact that pyramid workers received beef regularly tells us they were valued members of society engaged in important work, not disposable slaves. Medical examinations of skeletal remains from these workers' cemeteries reveal another fascinating detail. Many of the workers received medical care for injuries, including sophisticated surgeries. Bones show evidence of fractures that were set and healed, limbs that were amputated with care, and even evidence of successful brain surgery. Slaves aren't typically given this level of medical attention. These were skilled workers and craftsmen whose value to the project justified investment in their health and well-being. So, who were these workers? The evidence suggests they came from several different groups. First, there was a core group of permanent workers, skilled craftsmen, engineers, architects, and specialists who worked year-round on the project. These might number in the thousands. They were professionals who had trained for years to master their crafts, stone cutters who could shape blocks with precision, surveyors who could maintain the geometric accuracy of the structure, engineers who designed the internal chambers and passages, artists and craftsmen who created the inscriptions and decorations. Second, there was a much larger group of seasonal workers, probably farmers from throughout Egypt who came to work on the pyramids during the annual Nile flood, when their fields were underwater and agricultural work was impossible. This would have been seen as a form of national service, similar to taxation. Instead of paying money to the state, you paid in labor. These seasonal workers might have numbered in the tens of thousands at peak times. This system was actually quite ingenious from a governmental perspective. The annual flood made farming impossible for several months each year. Rather than having a large population sitting idle, the state mobilized them for massive construction projects. This served multiple purposes. It created monuments that glorified the pharaoh and the gods. It provided employment and food for the population during a period when they couldn't support themselves through farming, and it reinforced the pharaoh's authority and the unity of the Egyptian state. Third, there were support workers, people who didn't work directly on construction but kept the project running. Bakers who produced thousands of loaves of bread daily, brewers who made beer, which was safer to drink than water and provided calories and nutrition, butchers who processed cattle and fish, potters who made vessels for storing and transporting food and water, basket weavers, rope makers, tool makers, administrators and scribes who kept records, medical personnel who treated injuries, guards who maintained order. The scale of the support infrastructure was enormous. Recent archaeological excavations have revealed bakeries at the pyramid sites that could produce 10,000 to 15,000 loaves of bread per day. That's not ancient propaganda. That's based on the physical size of the ovens and calculations of their capacity. Think about what that means. These weren't small operations. They were industrial-scale food production facilities. The amount of resources required to feed, house, and support this workforce was staggering. Estimates suggest that feeding the pyramid workforce required thousands of cattle, tens of thousands of sheep and goats, and vast quantities of fish, bread, and beer annually. This food had to come from somewhere, which means ancient Egypt's agricultural system was productive enough not only to feed the general population, but also to generate substantial surpluses that could be redirected to these projects. How was all of this organized? This is where ancient Egyptian administrative sophistication really shines. We have written records on papyrus and carved inscriptions that give us glimpses into the bureaucratic machinery that made these projects possible. The workforce was organized into gangs with names like Friends of Khufu or Drunkards of Menkaure. These weren't just random labels. They represented organized work units with specific assignments and probably some sense of competitive pride. Within each gang were smaller groups called files, and within those were even smaller units. This hierarchical structure allowed for efficient management and coordination of thousands of workers. Each work unit would have had overseers responsible for specific tasks. There would have been quotas and productivity targets. Scribes would have kept records of what was accomplished each day. Quality control inspectors would have checked that work met standards. Supply chain managers would have ensured that materials arrived when and where they were needed. We even have surviving administrative documents that track specific deliveries of materials, record the names of work crews, and detail resource allocations. These aren't the records of a chaotic slave labor operation. They're the paperwork of a sophisticated bureaucratic system. The workers themselves probably had a complex social structure. Skilled craftsmen would have had higher status than general laborers. There would have been apprenticeship systems where younger workers learned from masters. There would have been competition between work gangs for prestige and probably extra rations. There would have been songs, chants, and rituals that helped coordinate work and build camaraderie. Archaeological evidence shows that workers' communities had their own internal organization. There were different grades of housing, suggesting social stratification even within the worker population. There were areas for religious observance, small shrines and temples where workers could make offerings to the gods. There were areas for recreation and socializing. Life as a pyramid worker was undoubtedly hard. The work was physically demanding, the conditions were harsh, and injuries were common. But it wasn't the life of a slave. Workers were participating in what they believed was sacred work, building a gateway to the afterlife for their god-king, ensuring the prosperity and stability of Egypt through proper religious observance. This religious and cultural motivation cannot be understated. It's what made the entire enterprise possible. Think about other massive construction projects throughout history that were completed successfully. Medieval cathedrals took decades or even centuries to build, with multiple generations of craftsmen dedicating their lives to the work. Why? Religious devotion and civic pride. The same motivations that built Notre Dame, or the great mosques of the Islamic world, are the motivations that built the pyramids. Modern project managers and organizational theorists who study the pyramids are often amazed by the level of coordination and planning evident in their construction. Managing a workforce of 20,000 to 30,000 people across multiple work sites. Coordinating supply chains that stretched hundreds of kilometers, maintaining quality control, and doing all of this without computers or even basic mechanical calculators represents organizational achievement that's remarkable by any standard. Some researchers have argued that the pyramid projects were instrumental in developing the administrative systems and bureaucratic structures that made Egyptian civilization so successful for so long. The challenges of organizing pyramid construction forced the development of record-keeping systems, supply chain management techniques, and hierarchical organizational structures that could then be applied to other aspects of governing a large, complex society. There's also evidence that work on the pyramids wasn't constant year-round, but followed seasonal patterns linked to the agricultural calendar. During planting and harvest seasons, much of the workforce would have returned to their farms. During the flood season and the slower agricultural periods, work on the pyramids would have intensified. This seasonal pattern actually makes sense from multiple perspectives. It allowed farmers to maintain their agricultural responsibilities while still contributing to national projects. It prevented workforce burnout. Several months of hard labor, followed by several months of different work, provided variety and recovery time. It also aligned with the natural rhythm of Egyptian life, which was deeply connected to the annual cycle of the Nile flood. The question of motivation is crucial. Why would tens of thousands of people willingly participate in such an enormous, difficult project? The answer is multifaceted. First, there was genuine religious belief. The ancient Egyptians believed that the pharaoh was a living god and that his successful transition to the afterlife was essential for the continued prosperity of Egypt. Building his eternal resting place was sacred work that brought blessings to those who participated. Second, there was economic benefit. Workers were fed, housed, and paid. For many farmers, the flood season meant idle time anyway. Working on the pyramids provided income and security during a period when they couldn't work their own fields. Third, there was social prestige. Being chosen to work on the pharaoh's eternal monument was an honor. Workers who distinguished themselves might receive recognition, rewards, or opportunities for advancement. The work gangs developed their own identities and pride in their contributions. Fourth, there was the simple human satisfaction of being part of something larger than oneself. The pyramids weren't just tombs, they were symbols of Egyptian power, sophistication, and divine favor. Workers could look at what they were creating and feel pride in their contribution to something that would last for eternity. This combination of factors, religious devotion, economic benefit, social prestige, and the satisfaction of meaningful work, created a workforce that was motivated, skilled, and incredibly productive. This is what made the impossible possible. Let's take a deeper look at the specific engineering achievements evident in the pyramids, because the more closely you examine these structures, the more impressive they become. Start with the foundation. The Great Pyramid sits on a platform of limestone bedrock that was carefully leveled. The builders didn't just build on whatever surface was available, They prepared the site with meticulous care. The core of the bedrock was left intact and incorporated into the pyramid's base, while channels were cut around it to create a level platform. This technique provided a stable foundation while minimizing the amount of unnecessary excavation. The leveling of this foundation is accurate to within centimeters across the entire base. To achieve this level of precision, the ancient Egyptians likely used water leveling, a simple but effective technique where channels are cut into the rock and filled with water, which naturally finds a level surface. By measuring relative to the water level and removing stone until everything matched, they could create a perfectly level platform. The four sides of the Great Pyramid's base form a nearly perfect square. The sides are 230.4 meters, 230.4 meters, 230.3 meters, and 230.4 meters. That's an average error of about 10 centimeters across sides that are over 230 meters long. The corners are almost exactly 90 degrees. This level of precision would be impressive even with modern surveying equipment. How did they achieve this? The ancient Egyptians used a combination of careful measurement using rope and wooden measuring rods, astronomical observation to establish true north, and probably wooden right-angle squares to ensure corners were accurate. But the remarkable thing isn't the tools they used, it's the care and precision with which they used them. The alignment to the cardinal directions is even more impressive. The Great Pyramid sides are aligned to true north, south, east, and west with an accuracy of about 3 arc minutes. That's 1/20th of a degree. To put this in perspective, many modern buildings aren't aligned this accurately. The ancient Egyptians probably achieved this alignment by observing the stars. By watching the rising and setting positions of stars over multiple nights and marking their positions, they could establish true north with remarkable precision. Some researchers believe they used a technique involving the circular path that stars near the pole appeared to trace across the sky, using careful observations to find the center of that circle, which would indicate true north. But why was this alignment so important to them? The pyramids weren't just tombs in the Egyptian understanding. They were machines designed to help the pharaoh's soul ascend to the heavens and join the gods. The alignment to the cardinal directions had religious and symbolic significance. The north was associated with the circumpolar stars, the indestructible ones that never set and represented eternity. The east was associated with the sunrise and rebirth. This careful alignment was an essential part of the pyramid's religious function. Inside the Great Pyramid, the engineering becomes even more sophisticated. The internal chambers and passages represent solutions to complex engineering challenges. The king's chamber is located near the center of the pyramid, about 43 meters above the base. This chamber is approximately 5.2 meters wide, 10.8 meters long, and 5.8 meters high. The walls are made of granite blocks, some of which weigh 80 tons. The ceiling consists of 9 granite slabs, each weighing approximately 50 tons, laid side by side to span the width of the chamber. Now, think about the engineering challenge this represents. These massive granite slabs are supporting hundreds of thousands of tons of stone above them. If they were simply laid flat, the enormous weight would cause them to crack and collapse. The ancient Egyptian engineers understood this problem and solved it brilliantly. Above the king's chamber are 5 stress-relieving chambers separated by 4 sets of granite beams. These chambers distribute the enormous weight of the pyramid above, preventing it from crushing the king's chamber. The uppermost of these relieving chambers has a pointed roof made of limestone blocks arranged at an angle. This creates a structure that redirects the weight outward and downward, further protecting the chambers below. This isn't a simple solution. It's sophisticated structural engineering that shows a deep understanding of how forces distribute through stone structures. The ancient Egyptians didn't have mathematical equations to calculate stress and load distribution, but they clearly understood these principles through observation, experimentation, and accumulated knowledge from previous building projects. The Grand Gallery is another engineering marvel. This is a 47-meter-long ascending passage with a ceiling that rises 8.6 meters high using corbelled arches. A corbelled arch is created by stacking stones, so that each layer projects slightly beyond the one below it until they meet at the top. The Grand Gallery's corbelled walls lean inward at precisely calculated angles to create a stable, self-supporting structure that has survived 4,500 years of supporting immense weight above it. The passages throughout the pyramid maintain consistent dimensions and alignments over long distances. The descending passage runs for over 100 meters at a precise downward angle, maintaining alignment that varies by only a few centimeters across its entire length. Cutting and aligning such passages through solid limestone and granite with only copper tools and rope plumb lines is an extraordinary achievement. The pyramid's internal chambers also demonstrate knowledge of ventilation. The King's Chamber and Queen's Chamber both have small shafts that run from the chambers through the body of the pyramid to the outside. For years, these were thought to be air shafts, but they were originally sealed so they couldn't have provided ventilation during construction. Modern researchers believe they may have had symbolic significance, perhaps representing paths for the pharaoh's soul to ascend to the stars. Or they may have served some other purpose we don't fully understand. The external casing stones that originally covered the pyramid were cut and fitted with extraordinary precision. These were blocks of fine white Tura limestone, cut to exact angles so that they fit together seamlessly and created the pyramid's smooth, gleaming surface. Each casing stone had to be cut to a slightly different angle depending on where it sat on the pyramid's face, because as you move up the pyramid, the angle relative to the vertical changes. The ancient masons had to calculate and cut potentially thousands of different angles with precision. Most of these casing stones were removed centuries ago to build other structures in Cairo, but some remain at the top of Khufu's pyramid and at the base of the Great Pyramid. Examining these remaining stones shows the incredible quality of the workmanship. The surfaces are smooth and flat to within millimeters. The angles are precise. The joints between stones are nearly invisible. The pyramids also demonstrate sophisticated understanding of structural stability. The center of the Great Pyramid consists of lower quality, roughly cut blocks, while the higher quality, precisely cut blocks are used for the outer faces and internal chambers. This isn't sloppiness, it's efficient engineering. The core blocks don't need to be as precisely cut because they're not visible, and they're supported on all sides by surrounding blocks. By reserving the most careful work for where it mattered most, the builders saved enormous amounts of time and effort without compromising structural integrity. The angle of the pyramid's faces, approximately 51.8 degrees, wasn't arbitrary. This angle represents an optimal balance between height, for visual impact and symbolic significance, and structural stability. Steeper angles would make the structure unstable and prone to collapse. Shallower angles would require more material for the same height and would be less visually impressive. The ancient Egyptians experimented with different angles in earlier pyramids and eventually settled on this optimal design. The bent pyramid at Dashur provides direct evidence of this experimental process. The lower portion of this pyramid rises at an angle of about 54 degrees, but partway up, the angle changes to about 43 degrees, creating the pyramid's distinctive bent profile. Why did they change the angle? The most likely explanation is that the steeper angle was causing stability problems, perhaps some cracking or settling in the structure. The builders recognized the problem mid-construction and adjusted their design, creating a shallower angle for the upper portion to ensure the pyramid wouldn't collapse. This trial and error process is visible throughout the evolution of pyramid construction. The step pyramid of Djoser, built earlier, is essentially a stack of increasingly smaller mastabas, flat-topped rectangular structures piled on top of each other. It was an experimental structure, testing whether massive stone structures could be built safely. Later pyramids show increasingly sophisticated techniques, culminating in the geometric perfection of the Great Pyramid. The ancient Egyptians also understood the importance of drainage. The Giza plateau receives occasional heavy rains, and without proper drainage, water could infiltrate the pyramid structure, causing damage through freeze-thaw cycles and erosion. The builders incorporated drainage channels and used impermeable fine limestone for critical areas to protect the internal chambers from water damage. Every aspect of the pyramid's construction shows evidence of careful planning, sophisticated understanding of engineering principles, and attention to detail that's extraordinary by any measure. These weren't primitive people building through trial and error. These were sophisticated engineers solving complex problems with elegance and efficiency. Let's talk about time. Specifically, let's talk about the timeline for building the Great Pyramid and what that timeline tells us about ancient Egyptian project management capabilities. According to historical records, primarily from the ancient Greek historian Herodotus, The Great Pyramid took approximately 20 years to build during the reign of Pharaoh Khufu, while Herodotus was writing over 2,000 years after the pyramid was built, and some of his information is clearly incorrect. The 20-year timeline is generally accepted as roughly accurate by modern Egyptologists. 20 years might sound like a long time, but when you consider what needed to be accomplished, it's actually an astonishingly short period. Let's break down what needed to happen during those 20 years. First, the site had to be prepared. This meant leveling the bedrock foundation, establishing precise measurements and alignments, and setting up the infrastructure to support the construction process. Worker housing, supply depots, tool manufacturing facilities, and so on. This preparation phase probably took at least a year, possibly two. Then came the actual construction, quarrying, transporting, and placing 2.3 million stone blocks. As we calculated earlier, this means an average of one block every 4.5 minutes, working 10 hours a day every day for 20 years. But the reality was probably more complex than this average suggests. Construction wouldn't have proceeded at a constant rate. In the early years, working at ground level, blocks could be placed relatively quickly. As the pyramid grew taller and ramps had to be extended, or internal passages had to be created, the rate would have slowed. The internal chambers and passages would have required careful, time-consuming work that would have occurred simultaneously with the placement of the main structure blocks. The external casing stones would have been placed as the pyramid neared completion, probably working from the top down, removing or dismantling ramps as the casing stones sealed each level. This final phase would have been slow and painstaking, as each casing stone had to be cut to a precise angle and fitted perfectly. To maintain this pace of construction, every aspect of the operation had to be carefully managed. The quarries had to produce blocks at a rate that matched consumption at the construction site. Transportation systems had to keep up. Imagine the chaos if blocks arrived faster than they could be placed, or if the construction site sat idle, waiting for blocks to arrive. This required sophisticated logistics and planning. Project managers had to forecast needs months in advance, because ordering granite blocks from Aswan meant a journey of several months for those blocks to arrive. They had to maintain buffer stocks of blocks at various stages to smooth out variations in supply and construction rates. They had to coordinate the work of thousands of people across dozens of different locations and activities. Consider the challenge of tool management alone. Each copper chisel would dull after a few hours of use on limestone, even faster on granite. With thousands of workers, the number of tools that needed to be manufactured, distributed, collected for resharpening, and redistributed must have been enormous. There had to be systems for tracking tools, ensuring workers had the tools they needed when they needed them, and maintaining quality control over tool manufacturing. Or consider water management. Thousands of workers in the desert need lots of water. The technique of wetting sand to reduce friction required huge quantities of water. Where did it come from? How was it transported to where it was needed? How was it stored? The ancient Egyptians must have had sophisticated water management systems, probably involving large numbers of workers dedicated solely to water transport and distribution. Food management presents another enormous challenge. Feeding 20,000 to 30,000 people every day, year after year, requires industrial-scale food production and distribution. The bakeries we mentioned earlier had to operate continuously. Cattle had to be raised, transported, slaughtered, and distributed. Fish had to be caught and preserved. Beer had to be brewed in massive quantities. All of this required planning, coordination, and management systems that could handle the complexity. The ancient Egyptians undoubtedly used written records to manage all of this. Papyrus was relatively expensive, but for a project of this scale and importance, the investment in record keeping would have been essential. Scribes would have tracked deliveries, recorded work gang productivity, inventoried supplies, and maintained accounts of rations distributed. We have some surviving examples of these kinds of administrative documents from ancient Egypt, though not specifically from the pyramid projects. These documents show sophisticated accounting systems, detailed inventories, and careful tracking of resources. The administrative systems used for the pyramids were probably similar, but on a much larger scale. Project management also required leadership and decision-making systems. Who had authority to make decisions when problems arose? How were disputes resolved? How were changes to the plan approved and implemented? The ancient Egyptians must have had clear hierarchies and decision-making processes, probably with the chief architect or master builder reporting directly to the pharaoh or his designated representative. Quality control was another crucial management challenge. With thousands of workers and millions of blocks, maintaining consistent quality required constant vigilance. There had to be inspectors checking the work at every stage, examining blocks as they came from the quarries, checking placement accuracy at the construction site, verifying measurements and alignments throughout the process. The 20-year timeline also tells us something about ancient Egyptian confidence and stability. Starting a project that would take 2 decades to complete requires confidence that the political situation will remain stable, that resources will continue to be available, and that the workforce will remain committed. The fact that they succeeded tells us that ancient Egypt during this period was a relatively stable, well-organized society with effective governance. Compare this to many modern mega-projects, which often run years over schedule and millions or billions over budget. The Sydney Opera House took 14 years to build instead of the planned 4 years. The Big Dig in Boston took 25 years instead of the planned 10 years. The pyramids being completed on schedule, or close to it, represents project management success that many modern projects fail to achieve. There's also something profound about the intergenerational nature of these projects. Workers who began working on the pyramid as young men would have grown old while the pyramid was still being built. Master craftsmen would have trained apprentices who would have completed what their teachers began. The project spanned a significant portion of a human lifetime, requiring sustained commitment and vision. This long-term perspective is something we've largely lost in modern society. We focus on quarterly earnings reports and election cycles measured in years. The idea of committing to a project that will take decades, that might not be completed within your own lifetime, is foreign to most modern thinking. Yet the ancient Egyptians not only committed to such projects, they succeeded in completing them. Now, we need to address the elephant in the room: the alternative theories about how the pyramids were built. If you've spent any time watching documentary channels or browsing the internet, you've encountered claims that the pyramids were built by aliens, or by survivors of Atlantis, or using sonic levitation, or with some kind of lost ancient super technology. Let's be clear from the outset: these theories are not supported by evidence. They're entertaining. They make for compelling television, but they don't hold up to scientific scrutiny. However, they're worth discussing because they reveal something important about how we think about ancient accomplishments, and because addressing them helps solidify our understanding of how the pyramids were actually built. The ancient aliens theory, popularized by books and television shows, suggests that extraterrestrial visitors either built the pyramids or provided ancient Egyptians with advanced technology to do so. The argument usually goes something like this: the pyramids are so precise and sophisticated that primitive ancient people couldn't possibly have built them. Therefore, aliens must have been involved. There are numerous problems with this theory. First, it's based on a false premise that ancient people were primitive and unsophisticated. The archaeological evidence clearly shows that ancient Egyptians were highly intelligent, skilled, and capable of sophisticated engineering. Assuming they couldn't have built the pyramids is actually a form of temporal prejudice, the assumption that people in the past must have been less capable than we are. Second, the alien theory doesn't actually solve any problems. It just moves them elsewhere. If aliens built the pyramids, why did they build structures that perfectly fit into the evolution of Egyptian architecture? Why do earlier pyramids show clear signs of experimentation and learning? Why do some pyramids show evidence of construction errors or mid-project design changes? If aliens with superior technology built them, wouldn't they get it right the first time? Third, the alien theory requires us to ignore all the evidence we have of Egyptian construction techniques. We have ancient quarries with partially cut blocks. We have tool marks on stones. We have ancient drawings showing construction techniques. We have workers' villages and written records. We have the pyramids themselves, which show clear evidence of having been built using Stone Age technology. The alien theory requires us to dismiss all of this evidence without any compelling reason to do so. Fourth, and perhaps most damningly, the alien theory doesn't explain why aliens would build pyramids in the first place. Pyramids are essentially large piles of stones. They're impressive, but they're not particularly advanced from an engineering perspective. If aliens capable of interstellar travel wanted to leave monuments on Earth, wouldn't they use more advanced construction methods and materials? Wouldn't they leave behind something more obviously advanced than precisely cut stone blocks? The lost civilization theory is similar, but locates the advanced knowledge in a hypothetical ancient human civilization, often identified with Atlantis or some other legendary lost society. This theory suggests that survivors of this advanced civilization taught the Egyptians how to build the pyramids. This theory has similar problems to the alien theory. First, there's no archaeological evidence for any such advanced ancient civilization. We have extensive archaeological records from the periods in question, and they show a clear, continuous development of human societies. There are no mysterious gaps that could hide an advanced civilization. Second, like the alien theory, this doesn't explain why the pyramids fit so perfectly into the evolution of Egyptian architecture. If the knowledge came from outside, we'd expect to see a sudden leap in capability, but what we actually see is gradual development and improvement over many generations. Third, the lost civilization theory often relies on similarities between pyramids in Egypt and pyramidal structures in other parts of the world, particularly in Central and South America. The argument is that these similarities prove these civilizations must have been in contact, probably through an intermediary advanced civilization. The problem with this argument is that pyramids are not particularly surprising as a structural form. If you want to build something tall using stone blocks, the pyramid shape is one of the most stable and obvious solutions. It's wide at the bottom for stability and narrows as it rises. This is a form that emerges naturally from the constraints of the materials and the goal. Different civilizations arriving at similar solutions to similar problems is not evidence of contact. It's evidence of similar intelligent responses to similar challenges. Moreover, the pyramids in Egypt and Central America are actually quite different in important ways. Egyptian pyramids have smooth faces and were built as tombs. Mesoamerican pyramids typically have stepped faces and were built as temple platforms. The internal structures are different. The construction techniques show important differences. The similarities are superficial. They are both roughly pyramid-shaped, while the differences are substantial. The sonic levitation theory suggests that ancient Egyptians, or whoever built the pyramids, had discovered some technology that could use sound waves to make heavy objects float, allowing them to easily move massive blocks. This theory is sometimes supported by references to legends and myths about priests or magicians who could move objects with sound. While it's true that sound waves can exert force on objects, this is real physics called acoustic levitation. The amount of force required to lift even a 1-ton object would require sound so loud that it would be physically dangerous to anyone nearby. Lifting an 80-ton block would require sound levels that would literally shake apart anything in the vicinity, including the stone blocks themselves and certainly the human operators. There's also no evidence that ancient Egyptians had the technology to generate and focus sound with the precision and power this would require. Modern acoustic levitation requires sophisticated electronic equipment to generate and control sound waves. It can lift small objects in laboratory conditions, but scaling this up to construction-sized stones is not feasible even with modern technology, let alone ancient technology. The geopolymer theory suggests that the pyramid blocks weren't cut from solid stone, but were cast like concrete using a mixture of crushed limestone and some kind of ancient cement. This theory is more scientifically grounded than the alien or sonic levitation theories, and there has been serious scientific research into this possibility. However, the consensus among geologists who have studied pyramid blocks is that they are natural limestone, not cast geopolymer. Microscopic analysis of the blocks shows the fossilized shells and natural stratification that you'd expect in sedimentary limestone, but that wouldn't be present in cast material. There are also visible tool marks on many blocks consistent with cutting and shaping, not casting. While it's possible that some kind of concrete-like material was used for certain applications in ancient Egypt, the evidence strongly suggests that the main pyramid blocks were cut from natural stone, not cast. So, why do these alternative theories persist despite the lack of evidence? There are several reasons. First, they're entertaining. Stories about aliens and lost civilizations are more exciting than stories about careful planning, hard work, and sophisticated but understandable ancient engineering. Entertainment value doesn't make something true, but it does make it popular. Second, they appeal to a sense of mystery and wonder. Many people find it disappointing that the pyramids can be explained through conventional archaeology and engineering. They want there to be something more mysterious, more inexplicable, more magical about these ancient wonders. Third, these theories often reflect a genuine respect for the pyramid's impressiveness. The logic goes, these structures are so amazing that normal humans couldn't have built them. Therefore, something extraordinary must have been involved. Paradoxically, this line of thinking actually undervalues human achievement by suggesting that great accomplishments must have supernatural explanations. Fourth, there's sometimes an element of cultural prejudice at work. Some people find it easier to believe in aliens or lost super civilizations than to accept that ancient Africans could have possessed sophisticated engineering knowledge and organizational capabilities. This prejudice is usually unspoken and perhaps unconscious, but it's worth acknowledging. The truth is that conventional archaeology and engineering provide completely adequate explanations for how the pyramids were built. These explanations don't require us to invoke anything mysterious or supernatural. They do require us to recognize that ancient Egyptians were intelligent, skilled, organized, and capable. But that's not a difficult thing to accept. The real mystery isn't how did they build the pyramids with such primitive technology. The real mystery is how did they organize and motivate tens of thousands of people to work together on such an enormous project for so long? And that's a question about human society, culture, leadership, and organization, which is actually more interesting than aliens. As we near the end of our journey through the pyramid mystery, I want to step back and think about what these ancient monuments really represent and what they tell us about human beings and what we're capable of. The Great Pyramid of Giza weighs 6.5 million tons. It consists of 2.3 million precisely cut and fitted stone blocks. It was aligned to the cardinal directions with accuracy that wouldn't be exceeded for thousands of years. It incorporates sophisticated structural engineering that protected internal chambers from collapse under enormous weight. It was built in approximately 20 years by a workforce of perhaps 30,000 people using copper tools, rope, and wooden sledges. These are the facts, and they're extraordinary enough without any embellishment or supernatural explanation. But what do these facts tell us? They tell us that human beings working together can accomplish things that seem impossible. They tell us that with sufficient organization, determination, and sustained effort, we can move mountains. Or, in this case, create artificial mountains from carefully shaped stone. They tell us that our ancestors, living 4,500 years ago, were not primitive or simple-minded. They were intelligent, creative problem solvers who could plan for the long term, organize complex operations, and execute with precision that rivals modern standards. They tell us that technology, while important, is not the only measure of a civilization's sophistication. The ancient Egyptians lacked steel, electricity, computers, and combustion engines, but they possessed something equally valuable: social cohesion, organizational capacity, and the ability to mobilize and coordinate large-scale human effort toward common goals. Think about what it took to build the pyramids. It required vision. Someone had to conceive of these structures and convince others that they were worth building. It required planning. Every aspect of the project had to be thought through, from quarrying to transportation to construction. It required organization. Thousands of people had to be coordinated across multiple work sites and years of effort. It required trust. Workers had to trust that they would be fed, housed, and cared for. It required skilled craftsmanship. People had to master techniques and pass them on to others. It required quality control. Someone had to ensure that work met standards. It required resource management. Food, water, tools, and materials had to be procured and distributed. It required leadership. Difficult decisions had to be made and implemented. In other words, it required many of the same capabilities that modern mega projects require. The tools were different, but the fundamental challenges of managing large-scale human endeavors were the same. When modern engineers express amazement at the pyramids, what they're really expressing is respect for the organizational and logistical achievement. Moving stones is a solved problem. We have cranes and trucks. But organizing tens of thousands of people to work effectively toward a common goal for decades, That's still challenging, even with modern communication technology and management systems. The pyramids also tell us something about the power of shared belief and common purpose. The ancient Egyptians built these structures not because they were forced to, but because they believed in what they were doing. They believed that the pharaoh's successful transition to the afterlife was essential for Egypt's prosperity. They believed that contributing to this sacred work brought blessings to themselves and their families. They believed that they were part of something larger and more important than their individual lives. This kind of shared conviction is rare in modern societies. We're fragmented into competing interest groups, different beliefs, different goals. The idea that an entire nation could unite around a single project for decades is almost unimaginable to us. Yet the pyramids prove that it's possible, and that when it happens, the results can be spectacular. The pyramids also remind us of the value of patience and long-term thinking. 20 years is a long time to work on a single project. Workers who began as young men would be middle-aged by the time the pyramid was completed. They would never see the finished product in their youth. They had to trust that their efforts would eventually result in something magnificent. Modern society increasingly focuses on immediate results. We want fast returns on investment, quick solutions to problems, instant gratification. The idea of committing to something that will take decades to complete, that might not be finished in your lifetime, seems almost absurd. Yet some of humanity's greatest achievements, from medieval cathedrals to the pyramids, required exactly this kind of long-term commitment. The pyramids also demonstrate the power of incremental progress. One block every 4.5 minutes doesn't sound impressive, but sustained over 20 years, it results in one of the most impressive structures ever built. This is a lesson we often forget. Great things are rarely achieved in single dramatic moments. They're achieved through consistent, sustained effort over long periods. Think about your own life and goals. Whatever you're trying to achieve, whether it's mastering a skill, building a career, creating something meaningful, or improving yourself in some way, the pyramid principle applies. Small, consistent efforts, sustained over time, can produce results that seem impossible if you only look at what you can accomplish in a day or a week or a month. The pyramids also raise interesting questions about purpose and meaning. These structures served no practical purpose in our modern sense. They weren't housing, they weren't fortifications, they weren't infrastructure. They were religious monuments, eternal resting places for dead kings. From a purely utilitarian perspective, building them was a massive waste of resources that could have been used for other purposes. Yet clearly, the ancient Egyptians didn't see it that way. For them, these structures had profound meaning and purpose. They were investments in eternity, expressions of religious devotion, symbols of Egyptian power and civilization, and connections between the earthly and divine realms. This raises the question, what are we building today that will last 4,500 years? What are we creating that future generations will look at with awe and wonder? What are we doing that expresses our civilization's deepest values and beliefs? Most of what we build today is designed to last a few decades at most. We build for efficiency and practicality, not for eternity. We optimize for cost and function, not for symbolic meaning or aesthetic impact. There's nothing inherently wrong with this. It's a rational approach given our circumstances and values. But it does mean that we're unlikely to leave monuments that will inspire awe thousands of years from now. The pyramids also challenge our modern conception of progress. We tend to think of history as a straight line, moving from primitive past to sophisticated present to even more advanced future. But the pyramids complicate this narrative. In some ways, the ancient Egyptians achieved things that we struggle to match. They created structures of astounding precision and durability using simple tools. They organized and motivated massive workforces without modern communication technology. They planned and executed decades-long projects successfully. This doesn't mean ancient Egypt was more advanced than modern civilization. Obviously, we have capabilities they couldn't dream of. But it does mean that progress isn't simple or linear. Different societies develop different capabilities based on their circumstances, values, and challenges. The ancient Egyptians became incredibly good at moving and working stone because that's what their religion and culture valued and required. We've become incredibly good at other things based on what our society values and requires. The lesson is that we shouldn't underestimate past civilizations or assume that being ancient means being primitive. People in the past were just as intelligent as we are. They simply had different knowledge, different tools, and different priorities. The pyramids also serve as a reminder of what's possible when a society is stable, organized, and functioning well. Ancient Egypt during the Old Kingdom, when the Great Pyramids were built, was a society at its peak. It was unified under strong central leadership. It had productive agriculture, generating substantial surpluses. It had sophisticated administrative systems. It had skilled craftsmen and engineers. It had shared cultural and religious beliefs that unified the population. When all of these factors came together, the result was so spectacular achievement. The pyramids weren't flukes or anomalies. They were the natural product of a civilization operating at its full potential. This raises uncomfortable questions about our own civilization. Are we operating at our full potential? Are we organizing ourselves effectively? Are we pursuing goals worthy of our capabilities? Or are we squandering our potential on trivial pursuits and short-term thinking? The pyramids stand as evidence that human beings are capable of amazing things when properly organized and motivated. They challenge us to think bigger, plan longer, and aim higher. They remind us that the greatest obstacles to human achievement are often not technical, but social. Failures of organization, leadership, cooperation, and shared purpose. There's also something humbling about the pyramids. They've stood for over 4,500 years. Egyptian civilization itself lasted roughly 3,000 years, longer than any modern nation-state has existed. The pyramids have outlasted the civilization that built them. They've witnessed the rise and fall of countless empires, the birth of major world religions, the development of agriculture, writing, mathematics, science, and technology as we know it. They were ancient to the ancient Greeks. They were ancient to the Romans. They were ancient to medieval Europeans. They're ancient to us. And if human civilization survives, they'll still be ancient to people living thousands of years from now. This timeless quality gives them a special significance. They're not just historical artifacts. They're bridges across millennia, connecting us to our distant ancestors in a tangible, visceral way. When you stand in front of the Great Pyramid, you're seeing something that people in the Bronze Age saw, that Julius Caesar saw, that people throughout history have seen and marveled at. They remind us that we're part of a vast human story that stretches back into the deep past and forward into an unknowable future. They remind us of our mortality. The pharaohs who built them intended them as eternal monuments, yet the pharaohs themselves are long dead and mostly forgotten. They remind us that civilizations rise and fall, but great works can endure. Let's return to our central question. Did the Egyptians really build the pyramids? At this point, after everything we've discussed, the answer should be clear. Yes. Absolutely and unequivocally, yes. The evidence is overwhelming. Let's review what we know. We have quarries with partially extracted blocks and ancient tool marks showing exactly how stones were cut. We have workers' villages with housing, bakeries, breweries, and workshops showing where and how the workforce lived. We have administrative documents recording deliveries and work gang assignments. We have ancient Egyptian artwork depicting construction techniques. We have tool finds including copper chisels, stone hammers, and wooden sledges. We have the pyramids themselves, which show clear evidence of having been built using ancient techniques. We can see the evolution of pyramid construction over time, from early experimental forms to the refined geometry of the Great Pyramid. We can see evidence of trial and error, of learning and improvement, of human builders solving problems and refining their methods. We have scientific analysis of the stones confirming they came from known Egyptian quarries. We have structural analysis showing the sophisticated engineering principles built into the design. We have the testimony of ancient Egyptian texts describing the construction process. All of this evidence points in the same direction. The pyramids were built by ancient Egyptians using technology available to them at the time. Through careful planning, sophisticated organization, and sustained human effort over many years. There are still mysteries and unanswered questions, certainly. We don't know exactly which ramp system they used. We don't know the precise sequence of construction. We don't know all the tools and techniques they employed. These gaps in our knowledge are natural. We're trying to reconstruct events that happened 4,500 years ago with limited documentation. But these gaps don't justify wild speculation about aliens or lost super civilizations. They're simply areas where more research is needed, questions that future archaeological discoveries might help answer. Not knowing every detail of how something was done is not evidence that it wasn't done by the people who claimed to do it. The alternative theories we discussed earlier aren't just wrong, they're unnecessary. We have adequate explanations for how the pyramids were built. These explanations don't require us to invent new physics, invoke supernatural intervention, or imagine lost civilizations for which there's no evidence. They simply require us to recognize that ancient Egyptians were intelligent, capable, organized people who accomplished something extraordinary through hard work and ingenuity. Occam's razor, the principle that the simplest explanation that fits the facts is usually correct, strongly favors the conventional archaeological explanation, which is simpler, that ancient Egyptians built the pyramids using known technology over a 20-year period with a large workforce, or that aliens traveled across interstellar space to help build some precisely cut stone structures using methods that somehow left no trace of advanced technology. The archaeological explanation requires us to accept only things we know to be true, that ancient Egyptians existed, that they had the tools and knowledge we have evidence for, that they were capable of organizing large-scale projects, and that they valued these monuments enough to invest enormous resources in building them. All of these are well-established facts. The alternative explanations require us to accept things for which there's no evidence, that aliens exist, that they visited Earth, that they were interested in helping humans build stone monuments, that they somehow left no trace of their presence except for the monuments themselves, or that an advanced civilization existed for which we have no archaeological evidence, that it was destroyed so completely that it left no trace except for alleged influences on later civilizations. When you lay it out like this, the choice is clear. The conventional explanation is both simpler and better supported by evidence. There's also an ethical dimension to this question. When we attribute great achievements to aliens or lost civilizations, instead of to the people who actually accomplished them, we're diminishing human achievement. We're saying, in effect, that these accomplishments are so impressive that normal humans couldn't have done them. Therefore, something extraordinary must have been involved. This is particularly problematic when we're talking about the achievements of non-Western civilizations. The pyramids in Egypt, the megalithic structures in South America, the stone heads of Easter Island. There's a pattern of Western audiences being quick to attribute these non-Western achievements to aliens or lost civilizations. Meanwhile, Western achievements like Greek temples or Roman aqueducts are more readily accepted as products of human ingenuity. This double standard reflects cultural biases that we should acknowledge and resist. Ancient Egyptians were fully human, fully intelligent, and fully capable of amazing achievements. Recognizing this doesn't diminish the pyramids. It elevates humanity. It's also worth noting that professional archaeologists and Egyptologists, the people who have spent their careers studying these structures and the civilization that built them, are virtually unanimous in their conclusion that the pyramids were built by ancient Egyptians. The alternative theories are popular with the general public and make for entertaining television, but they're not taken seriously by experts in relevant fields. This doesn't mean we should simply accept expert opinion without question. Healthy skepticism is important. But when expert consensus is overwhelming and supported by extensive evidence, and when alternative theories are promoted primarily by non-experts and lack evidentiary support, we should be very cautious about rejecting the expert consensus. The scientific method requires that we base our conclusions on evidence, not on what we find exciting or mysterious or appealing. The evidence clearly supports the conclusion that ancient Egyptians built the pyramids. Does this make the pyramids less impressive? Not at all. If anything, it makes them more impressive. Understanding the enormous challenges involved in quarrying, transporting, and precisely placing millions of tons of stone using ancient technology makes the achievement more astounding, not less. Understanding the sophisticated organization and planning required makes us appreciate ancient Egyptian civilization more, not less. Understanding the human effort involved, thousands of people working together for decades, makes the accomplishment more inspiring, not less. The pyramids don't need aliens or ancient super technology to be amazing. They're amazing because of what they represent about human potential, about what we can accomplish when we work together toward common goals with determination and skill. They're amazing because they show us that our ancestors 4,500 years ago were sophisticated engineers, careful planners, skilled craftsmen, and capable organizers. They're amazing because they've stood for millennia as testaments to human achievement. They're amazing because they remind us that the greatest obstacles to human achievement are not technical, but social. Failures of cooperation, organization, and shared purpose. When we overcome these social obstacles, as ancient Egypt did during its Old Kingdom period, we can accomplish things that seem impossible. The real story of the pyramids, the true story, supported by archaeological evidence and scientific analysis, is more inspiring than any alternative theory involving aliens or lost civilizations. It's a story about human beings doing something extraordinary through intelligence, effort, and cooperation. It's a story that should fill us with pride about what our species is capable of, and it should inspire us to aim high in our own endeavors. As we approach the conclusion of our journey, I want to talk about what lessons we can draw from the pyramids for our own time. These ancient monuments have much to teach us about organization, planning, purpose, and human potential. The first lesson is about the power of long-term thinking. The pyramid projects required sustained effort over decades. Workers had to trust that their daily labor was contributing to something that would eventually be magnificent, even though they might not live to see it completed. Leaders had to plan years in advance, ensuring resources would be available when needed. Modern society increasingly lacks this long-term perspective. We focus on quarterly earnings, election cycles, and viral moments. We want immediate results and instant gratification. Long-term projects are often abandoned before completion because the benefits aren't immediately visible. Yet many of our greatest challenges, climate change, infrastructure development, education reform, scientific research, require exactly the kind of sustained, long-term commitment that built the pyramids. We need to rediscover the ability to start projects that might take decades to complete, to invest in things whose benefits might not be realized for years or generations. The second lesson is about the importance of shared purpose. The pyramid projects worked because an entire society was aligned toward common goals. People understood why the pyramids were being built and believed in their importance. This shared conviction motivated workers, justified the enormous resource expenditure, and sustained effort over many years. Modern societies are fragmented. We disagree about fundamental values, goals, and priorities. We struggle to find common ground and shared purposes. This fragmentation makes it difficult to accomplish large-scale projects requiring sustained cooperation. We don't need everyone to agree about everything. Diversity of thought is valuable, but we do need to find areas of common purpose where we can work together effectively. The pyramids show us what's possible when a society achieves this alignment. The third lesson is about organization and planning. The pyramid projects required sophisticated logistics, careful coordination of thousands of workers, and systems for managing resources, tools, and supplies. The ancient Egyptians developed administrative systems that could handle this complexity. Modern organizations often struggle with similar challenges, despite having technology the ancient Egyptians lacked. We have computers and communication systems, yet projects still fall apart due to poor planning, inadequate coordination, or organizational dysfunction. The pyramids remind us that good organization and planning are more important than technology. The ancient Egyptians succeeded because they thought carefully about every aspect of the project, established clear systems and hierarchies, and maintained discipline and quality control throughout. The fourth lesson is about quality and craftsmanship. The pyramid builders didn't cut corners or do merely adequate work. They aimed for excellence in every aspect of the project. Blocks were cut with precision. Measurements were checked and rechecked. The overall design was executed with meticulous attention to detail. Modern society often prioritizes speed and cost over quality. We build things designed to last only as long as necessary, not for eternity. We optimize for efficiency rather than excellence. There are good reasons for this in many contexts, but we've perhaps gone too far in this direction. There's value in doing things well, in taking pride in craftsmanship, in creating things that will last. The pyramids have endured for 4,500 years because they were built to endure. What are we creating today that will last even a fraction of that time? The fifth lesson is about what motivates people. The pyramid workers weren't slaves forced to labor under threat of violence. They were people who believed in what they were doing, who receive fair compensation for their work, who took pride in their contributions to something larger than themselves. Modern management theory has rediscovered these principles after decades of treating workers as mere cogs in machines. People work best when they understand the purpose of their work, when they feel valued and respected, when they see themselves as contributors to something meaningful. The ancient Egyptians understood this thousands of years ago. The sixth lesson is about the relationship between constraints and innovation. The ancient Egyptians achieved remarkable things despite severe technological limitations. They couldn't simply throw modern machinery at problems. They had to think creatively, to experiment, to find clever solutions using limited tools. Modern society tends to solve problems by throwing technology and money at them. This works sometimes, but it can also lead to lazy thinking. The pyramids remind us that constraints can drive innovation, that working within limitations can produce creative solutions that might not emerge if we simply relied on brute force technological approaches. The seventh lesson is about the value of accumulated knowledge. The pyramid builders didn't start from scratch. They built on centuries of experience with stone construction, learning from earlier projects, refining techniques over generations. The Great Pyramid represents the culmination of a long process of learning and improvement. Modern society sometimes acts as though we can ignore history and start fresh with each generation. We reinvent wheels, repeat mistakes, and fail to learn from past experience. The pyramids remind us that great achievements build on accumulated knowledge passed down and refined over time. The eighth lesson is about priorities and values. Ancient Egypt invested enormous resources in building structures that served primarily religious and symbolic purposes. By modern standards, this might seem irrational. Shouldn't they have spent those resources on practical things that would improve people's daily lives? But the ancient Egyptians clearly felt that these monuments were worth the investment. They served purposes that the ancient Egyptians valued, honoring the gods, ensuring the pharaoh's successful transition to the afterlife, expressing Egyptian power and civilization, creating connections between earthly and divine realms. This reminds us that different societies value different things, and that there's no objectively right way to allocate resources. It also raises questions about our own priorities. We invest enormous resources in things that future societies might find strange or wasteful. What we choose to build and create reflects our values, just as the pyramids reflected ancient Egyptian values. The ninth lesson is about human capability and potential. The pyramids prove that human beings working together can accomplish things that seem impossible. We can move mountains, create structures that last millennia, and leave marks on the world that endure long after we're gone. In an age when many people feel powerless in the face of large-scale problems, this is an important reminder. Yes, the challenges we face today are different from those faced by ancient Egypt, but the fundamental truth remains. Humans are capable of extraordinary things when we organize effectively and commit to common purposes. Climate change seems overwhelming. Poverty seems intractable. Political divisions seem unbridgeable. Technological risks seem unmanageable. But the pyramids remind us that previous generations faced challenges that seemed just as daunting, and they found ways to overcome them through cooperation, ingenuity, and sustained effort. The 10th lesson is about legacy and meaning. The pyramid builders created something that has lasted for over 4 millennia, something that continues to inspire awe and wonder. They created a legacy that far outlasted their own lives and their entire civilization. What legacy are we creating? What will people 4,000 years from now remember about our era? Will we leave behind anything of lasting value, or will our civilization be remembered only through archaeological remnants of our consumer culture? These are uncomfortable questions, but important ones. The pyramids challenge us to think about what we're building that will last, what we're creating that has meaning beyond immediate utility, what we're doing that future generations will look at with respect and admiration. So, we return to our original question. Did the Egyptians really build the pyramids? And the answer, supported by overwhelming evidence, is yes. They built them through a combination of factors that all had to align. Strong centralized leadership that could mobilize national resources, sophisticated engineering knowledge developed over generations, excellent organizational and administrative systems, a large workforce motivated by religious belief and fair compensation. careful planning and quality control, and sustained effort over many years. They built them not because they had alien help or lost super technology, but because they were intelligent, capable human beings who tackled an enormous challenge with determination, skill, and ingenuity. The pyramids are mysterious, not because we don't understand how they were built, but because they force us to reckon with the capabilities of our ancestors. They challenge our assumptions about progress and primitive peoples. They remind us that ancient doesn't mean simple or unsophisticated. They're majestic not because of anything supernatural about their construction, but because they represent human achievement at its most impressive. They show us what we can accomplish when we work together toward common goals with skill, organization, and sustained commitment. When you stand in front of the Great Pyramid, and if you haven't had the chance yet, I strongly encourage you to do so someday. You're not just seeing a pile of stones. You're seeing 2.3 million decisions to cut another block, to transport another load, to place another stone precisely in position. You're seeing 20 years of sustained effort by thousands of people. You're seeing the accumulated knowledge of generations of builders. You're seeing the organizational capacity of an entire civilization. You're seeing what humans can do when they aim high and refuse to give up. You're also seeing a monument that has outlasted the civilization that built it. The ancient Egyptian language isn't spoken anymore. The gods they worshipped are no longer revered. The political system that commanded these structures' construction has long since vanished. But the pyramids remain, testament to what those people accomplished. There's something profoundly moving about this. Empires rise and fall, religions come and go, technologies become obsolete, but great works can endure. The pyramid builders created something that transcended their own time, something that would speak to people across millennia. In our own age, when so much of what we create is digital and ephemeral, when buildings are designed to last decades rather than millennia, when we optimize for the short term rather than the long term, the pyramids stand as a challenge and an inspiration. They ask us, what are you building that will last? What are you creating that has meaning beyond immediate utility? What legacy will you leave? These aren't easy questions, and I don't pretend to have simple answers. But they're questions worth asking. The pyramids force us to think bigger, to imagine what's possible, to consider our place in the long arc of human history. They also remind us that our ancestors deserve respect. The ancient Egyptians were not primitive people who needed alien intervention to accomplish great things. They were sophisticated, intelligent, capable people who built one of the wonders of the world through human ingenuity and effort. Recognizing this doesn't diminish the pyramids, it elevates humanity. The story of the pyramids is ultimately a story about us, about human beings and what we're capable of. It's a story about intelligence applied to difficult problems. It's a story about organization and cooperation on a massive scale. It's a story about having vision and seeing it through. It's a story about leaving something behind that will outlast you. These ancient monuments, built by people who died over 4,000 years ago, still have lessons to teach us. They remind us that the greatest obstacles to human achievement are usually not technical, but social. Failures of organization, cooperation, shared purpose, and sustained commitment. When we overcome these obstacles, as ancient Egypt did, we can accomplish the seemingly impossible. They remind us that technology, while important, is not everything. The ancient Egyptians built the pyramids without steel, without combustion engines, without electricity, without computers. They succeeded through excellent organization, careful planning, skilled craftsmanship, and sustained effort. These remain important even in our high-tech age. They remind us of the power of long-term thinking and the value of projects that span generations. They remind us that great achievements require sustained effort over long periods, that immediate results are less important than eventual outcomes, that patience and persistence matter. They remind us that humans are capable of amazing things when we work together effectively. The individual workers who built the pyramids accomplished the extraordinary by acting collectively, coordinating their efforts, subordinating individual interests to common goals. As we face the challenges of our own time, climate change, technological disruption, social fragmentation, political polarization, the pyramids offer both inspiration and instruction. They show us that previous generations faced enormous challenges and found ways to overcome them. They show us what's possible when a society organizes effectively and commits to ambitious goals. They show us that human achievement is not limited by our technology, but by our imagination, organization, and determination. So, the next time you see an image of the pyramids, or if you're fortunate enough to see them in person, take a moment to really think about what they represent. Don't see them as mysterious anomalies that require supernatural explanation. See them as monuments to human capability, testaments to what we can accomplish when we work together effectively toward common purposes. See them as challenges to our own civilization. What are we building that will last? What are we creating that future generations will look at with awe? What are we doing that has meaning beyond immediate utility? And see them as inspiration. If ancient Egyptians could move millions of tons of stone with copper tools and rope, imagine what we can accomplish with modern technology and knowledge. If they could organize tens of thousands of workers across decades to complete an enormous project, imagine what we could do if we achieved similar levels of social cohesion and shared purpose. The pyramids are mysteries, not because we don't understand them, but because they force us to confront uncomfortable truths about our own limitations and untapped potential. They're majestic not because of anything supernatural, but because they represent the best of what humans can be and do. Did the Egyptians really build the pyramids? Yes, without question. And that fact, that ordinary humans using ancient technology accomplish something that still astounds us today, is far more inspiring than any alternative theory involving aliens or lost civilizations. The real mystery of the pyramids is not how they were built. The real mystery is why we don't accomplish similarly audacious projects today, when we have so many advantages our ancestors lacked. The real mystery is how we've lost some of the capabilities ancient societies possessed. The ability to plan for the long term, to sustain effort across generations, to organize large-scale cooperation, to create things meant to last for eternity. Perhaps the greatest lesson of the pyramids is this: we are capable of so much more than we typically achieve. The ancient Egyptians proved it 4,500 years ago. The question is whether we'll learn from their example and apply it to the challenges of our own time. Thank you for joining me on this journey through one of history's greatest mysteries and most magnificent achievements. I'm Earth Mist, and I hope this exploration of the pyramids has given you a deeper appreciation for ancient Egyptian civilization, for human capability, and for what we might accomplish in our own time if we set our minds to it. The pyramids stand today as they have for over 4 millennia, silent witnesses to human ambition, ingenuity, and perseverance. They were built by humans for human purposes, using human intelligence and effort, and that fact makes them not less wondrous, but more so. Until next time, keep questioning, keep learning, and never underestimate what humans can accomplish when we work together toward great purposes. Before we close, it's worth noting that while we have solid answers to the main questions about pyramid construction, research continues and new discoveries are still being made. In recent years, new scanning technologies have revealed previously unknown voids within the Great Pyramid, suggesting there may still be undiscovered chambers or passages. These discoveries use cosmic ray detection and other non-invasive imaging techniques to peer inside the structure without drilling or excavating. Archaeological work continues at the workers' villages and quarry sites, gradually revealing more details about the lives of the people who built these monuments. Every new discovery adds to our understanding of ancient Egyptian society and construction techniques. Modern engineering studies continue to test theories about construction methods. Researchers build scale models and conduct experiments to better understand what did and didn't work. Each experiment either confirms existing theories or suggests new possibilities. Egyptologists continue to discover and translate ancient texts that may contain relevant information. While we're unlikely to find a complete instruction manual for pyramid building, such practical knowledge was probably passed down orally from master to apprentice rather than written down. We continue to find documents that shed light on the organization and administration of these projects. Chemical and geological analysis of the stones continues to provide information about exactly where different stones came from and how they were worked. New analytical techniques allow us to extract more information from the physical evidence. The study of the pyramids is far from complete. There are still questions to answer, mysteries to explore, and discoveries to be made. But the fundamental question, did the Egyptians build the pyramids, has been answered beyond reasonable doubt. As research continues, we'll undoubtedly refine our understanding of the specific techniques used, the organization of the workforce, and the precise sequence of construction. But the basic story is clear and well established. The pyramids were built by ancient Egyptians through a combination of sophisticated engineering, excellent organization, skilled craftsmanship, and sustained human effort over many years. No aliens, no lost super civilizations, no magical technology, just smart, capable humans accomplishing something extraordinary. And that's the story that should inspire us most. Because if they could do it, what might we accomplish?